the paper with the ink part down. So yeah.
So what did you discover? That it was forming on the other side? Is that what you're trying to tell your friends?
Yes, that it also formed on the other side of the paper and also like the same shape and size.
Okay. It forms the same shape. Did you look at the distance from your folding line? Vanessa?
Yes.
Did you try to analyze the distance from the ink to the folding line? And then the distance to that other point you formed opposite?
I didn't really focus on the distance, but I didn't focus on the distance, but on either side of like the fold part was equal to like the other part of the ink.
Okay. Joseph, can we hear from some other person? Thank you, Vanessa. That was good of you.
Let's hear from Charity. Charity, then our difference.
I carried out the experiment, and after putting the ink and paper and left it for some time to dry, when I opened it, the ink had also gone on the other side of the paper, and it was the same size and shape. And then after, the distance from one spot of ink to the fold line was the same distance from the other spot of ink to the fold line. Yeah, then the angle between the line and the fold, I didn't exactly get what angle they meant, but if they're to mean like the fold line and the line from one spot of it to the other, I think it would be 90 degrees, though I didn't understand what angle they meant. That's what I got.
Okay, yes. Thank you, Charity. Adifo.
Teacher also carried out the experiment. I put a drop of ink on one side of the paper, then I folded it and I left it to dry. After that, it formed an irregular shape on both sides of the paper, and there were the same size and the difference, the distance from the middle line and from the fold line and the spots of ink were the same, and also the second question was to measure the angle between the two lines and fold, and I got minus 90 degrees.
Okay, thank you, Crown. Before we go to Marjorie, let me hope our friends here, if they didn't, they're able to try out now, because it will be better if everyone tried out that thing. It is very interesting. So don't just listen in, but get a paper, do what you're doing. You fold that paper, then get some ink from your pen, one side of the paper, then you fold again, press that paper, and then after analyze what really happens. The size of the ink, will it mark itself on the other side? Those are the points we want to single out. So friends who are also listening in, please try out that experiment as well. We want to have you on board right here. Okay, Marjorie, let's hear from you. What you really observe there.
I also got a piece of paper. I folded it and I also poured ink. So I pressed it. So after pressing it, I let it for some time for 3 minutes. The ink was equal to the ink of this size. So yeah, that's out. I didn't measure the distance from the folding line. Ink, so I found that the ink went to the other side, and it was the same size of the ink. So the same size. That's what I found out.
Okay, thank you, Marjorie. Do you have any other person who has just tried out that experiment right now? We hear from that person. If you have tried out, please put up your hand right now. We want to have you on board as a class. Please try to experiment that. Very important moving forward. All right there.
Okay, I'm seeing Daniela Sekirai. Can we hear from you, Daniela? Daniela?
Pardon, yeah?
Can we hear from you? I see your hand is up. Did you try out the activity? Yes, Daniela? Okay, it seems
Hello?
Yes, Daniela, can you speak to us, please? I guess our network has a problem. Maybe we'll get back to you, Daniela, later. Any other person who tried out this activity which is showing on your screen? Joseph, are you seeing any hand from your end?
No, I only see Juliana, your mic is open. I don't know whether they want to say something. But if you want to say something, please just put up your hand. You don't need to try now.
Joseph, no other person?
I don't seem to see any other person.
Okay,
but
great.
Our friends here should know that we are dealing with that activity 2.1 on page 106. As getting a paper, then you get some ink from your pen. Okay. Before it dries, you fold your paper.
Actually, they can write using a paper by just drawing a dot and then they, rub it several times. It can still work.
Mm-hmm. Okay.
So maybe in the interest of time, we can try to demonstrate it and to move on. Okay, girls, I don't know if my screen is visible to everyone.
No.
I'm sharing.
For me, it isn't.
The white screen is is still sharing. Guess it's the network. Yes. Is it visible to anyone yet?
There is nothing there.
Okay, fine. Let me stop sharing and I try again.
Yes. We as well have teacher Jennifer on board. Close right there below teacher Martha.
Okay, she's welcome. I don't know if my screen is seen now.
No.
Okay, I guess there is a challenge with the network, maybe. That's why it's delaying to show. But I was trying to share my screen. So if there is no one who is viewing it from that end, Joseph, I don't know if you are using a phone, eh?
Yes.
Might be hard for you to do this activity. Okay.
You're
Yes?
You're sharing right now.
Okay, if it's
cannot see it.
Okay, great. If it's visible now, then the activity we are telling you to do, assuming this is my paper, what you are seeing in red, it's just a piece of paper. And assuming I just put a dot there, okay? So we're telling you to fold this paper along the black line. So when you fold it, it should be able to form on the opposite side, okay? It should be able to form on the opposite side, okay? When you fold and then you open, you're going to fold along the black line. So when you open it, it's going to show two dots, one, the original dot, and then the other one, the second dot, which is formed as a result of folding along the black line. Now, this experiment was supposed to lead you to some of the terms that we are going to be using. And the first term is the line of symmetry. The line of symmetry is that line we are folding from. In a simpler language, I can say that it's acting like a mirror, okay? So it's mirroring the first dot to the second dot, okay? So if this is my first dot, then it's being mirrored to that, okay? So the first dot and the second dot are similar. They have the same size and same shape. And then the other thing you need to note is the distance from the mirror line, okay? The distance is the same. The distance, this distance here, okay, is the same as that distance. So those are the two key things I want you to note as we start on this topic, that if you reflect an object in a line, which we are calling line of symmetry, okay? Sometimes they are going to be calling it a mirror line. So when you reflect a point through that line of symmetry, it's going to be reflected on the opposite, and it will be having the same distance from the mirror line, okay? So object distance is equal to the image distance. And then the two shapes, the object and the image have the same shape and same size, okay? I don't know if that helps. Does it help?
Yes, teacher.
Yes.
Now, the other thing they wanted you to note was the angle formed. You realize that when you join these two, they are meeting the mirror line at an angle of 90. We see that? We see that these ones are meeting at an angle of 90. So they wanted you to deduce that as well, that if you join the object and the image, they make an angle of 90 with a mirror line, okay? Or the line of symmetry, okay? So those are some of the key things that that activity was supposed to help you pick before we can start using them, because you need that knowledge for you to able to do this topic with ease. If you can't know that if I reflect an object through a line, it's going to be reflected on the opposite side, and then you have the two having equal distances, and then the line joining the object and the image is perpendicular to the mirror line, or it meets it at an angle of 90. Then it's going to be hard for you to do this topic. But the topic is very easy. You just need to know how to draw your mirror line, and then you just need to know how to measure the distance from the mirror line, because without knowing how to do that, it's going to be hard for you. Okay, and in this topic, we expect you to have a graph book. Okay, because you're going to be using graph papers to work out these questions. Okay, Joseph, anything you want to share, or any of the teachers, Teacher Math and Teacher Jennifer?
Thank you, Theo. I think you have said it all. We had already given them a background of what they need, but you have explained very well. But we have a hand up. We have Chiravo Hope.
Okay.
Chiravo, you can unmute.
Can we hear from her?
Chiravo, I think we have lost her. Marjorie, you can unmute.
I was asking, is it or is it 90 degrees, or is it holding line of symmetry?
I didn't get your question right.
I'm asking, is it or is like at 90 degrees, or is according to how you folded? Okay, the folding lines. I don't know how can I explain.
Okay, Marjorie, when you reflect through a line, okay, the object and the image should always meet the image, the mirror line at an angle of 90, always.
Okay, okay, teacher.
Do we have
Okay.
more?
Yes, we have Hope. is back. Yes. Yes, please go on. Okay. All right, noted. We have noted that hope, no problem. Let's take Queen as well at once, such that we answer at once. Queen.
I was asking, like, if you get a paper, maybe this side is smaller than the other side, then after you fold, then would still the angle be 90 degrees?
Okay. I think the size of the paper or where you draw the line doesn't matter. What matters is where your image is and where your object is. Okay. At the end of the day, you might have a paper which is bigger like that, but the only part which you're using is what matters. We're interested in this area only. Okay. So whichever area is after the object and the distance, it's not a big issue. Okay.
Yes.
Yeah, but we are going to look at some shapes shortly, and then you'll see the importance of having the line of symmetry. Yes, Joseph?
Yes. Maybe the other thing, what they should note is that at least if they're having paper, they should try to approximate the midway, and when they don't measure, because one can put, I don't know, you can try to draw some kind of a demo there. One can have a paper and then tries to fold with one part very small, okay? And then on putting the mark, the ink on the other big side, you can find that on folding back, the ink will be outside the other page. So that won't be making sense. Maybe we draw this side on the left. Yes. So maybe if you hold at that point, yes, at that point.
I think what you're trying to tell them is when you're folding, it's proper to approximately divide the paper into two equal parts, because if you divide it poorly, you'll have that one side is bigger than the other. And when you fold, you'll see that this side is outside the other shape. Eh?
Yes, very good.
For example, if my ink is, my diagram is there. My ink is here. If you fold, you realize that the distance, this distance here, bigger than, you'll find that, you fold, you'll find that your dot is outside the page. Eh? So it is proper to always balance the paper so that you have a part where it can easily map itself. Eh? Okay?
Yes.
Okay, Joseph. Yes.
Remember, we have the other concern of Hope. Hope was saying that she had the issues. Eh? Maybe you can repeat, because we will have other friends still joining. I think that will be very important as well. If we briefly repeat this first step, how we can the page, draw that symmetrical line, then fold, include the mark there. Yeah, I think.
Are you talking of this?
Yes.
Okay, we can repeat once more for those who have just joined. So I said, if this is your piece of paper, okay, and they're asking you to put a dot on one side and then you fold the paper into two equal pieces so that that dot is reflected on the other side or is mapped on the other side. So I said it's important to divide that piece of paper into two equal parts. And if I put a dot the other side, okay, and then I fold my paper along this black line, then this dot is going to be mapped on the opposite end, okay? It's going to be mapped on the opposite end, approximately the same distance from the this black line. The black line, I said it's a mirror line or the line of symmetry. Line of symmetry is the line that divides a shape into two equal parts. So in this case, I'm dividing my paper into two equal parts. I said the distance from the line of symmetry to the object, this distance is approximately equal to that distance, okay? And I said, if this is my object, then this is my image, okay? So I'm having this dot mapped on the other side. So we are having two of them, and the line is acting like a mirror. It's reflecting the object on the opposite end, okay? And if you join the two, if you join the image and the object, they will meet the mirror line at an angle of 90, okay? So those are some of the key things our friends who have just joined need to know, okay?
Yes, thank you.
Okay, can we move on, Joseph?
Yes, we can. You can move on, no problem. Unless there's any other concern, but I don't seem to see any right now.
Okay, let me try to share the learner's guide. So they were supposed to do that activity and it was supposed to help them deduce those key things that they need as they do the rest of the work. They need to know what a line of symmetry is. And I've just said a line of symmetry is a line which divides any shape into two equal parts. Then they need to know that the distance from where the object is to the line of symmetry is equal to the distance from where the image is to the line of symmetry. So they need to admit to know that. And then the angle that's the line that's joining the image and the object meets the line of symmetry at an angle of 90. So when they ask you to reflect, then we'll expect you to know that your object, the line from your object to the line of symmetry is 90, just as the line from the image to the line of symmetry is also 90. Okay, Joseph, there is an exercise here which they were supposed to do to determine how many lines of symmetry they can attain from a rectangle. But in the interest of time, I'm going to play for them a video which should give them an idea of how they are going to do this. And then during their free time, they'll try to finish that.
Yes, that's very important right there.
Okay, maybe as we attend to those hands.
Okay, Marjorie, your hand is up. Please unmute.
Teacher, to ask when I want to measure the distance from one point to the fold line and the distance from the first point of the fold line, I have to get a rule and I measure like from the point where I draw it off is to the mirror line and from the reflection to the mirror line, or it's something else.
No, now the easier way is to get your ruler. Okay, I think just you a minute. A ruler. You draw a horizontal line joining the two ink marks you have on your paper. Okay, it should be horizontal. Don't mind even when it runs through that fold line. Keep it horizontal, joining the two ink marks. Then from that you can measure the distance from the one which you have as the object, first one, to the fold line. Measure the distance. After noting it, try and measure the other distance as well, from the fold line to the other ink are formed. And then see whether that distance will be the same.
Okay.
That's what you need to do. But draw one to the fold line and then the other, that will disturb you a little bit. So draw one line joining the two ink marks running through the fold line. Then you can thereafter measure from that point. Let me hope that is okay now.
Okay.
All right.
Yeah, but Joseph, they need to understand that the reason why we are asking them to use graph books, because they're going to be plotting points, or they can have different shapes. And then they need to know how those shapes are going to behave when you reflect them through the line of symmetry or the mirror line. Okay. So I want them to basically understand the key things that we've just told them. The image distance and the object distance are equal from the line of symmetry. And then the object size and shape is same as the image size and shape. Okay. Yeah, so basically they need to have that at the back of their mind as they are doing this. And then the questions that are going to be setting for them, they'll always tell them in which line they are supposed to reflect their points or their shape. Because you'll be having the Cartesian plane, which is the XY plane. You have the vertical line and the horizontal line. And then they'll ask you to reflect either in the vertical line or in the horizontal line. So depending on where your point is or where your shape is, then you reflect accordingly, okay? Of course, at some point they can reflect through a slanting line, but for now, I think they are going to be using those two lines. So I don't know if you're having questions.
We have Crown. If you attend to her,
The
then
question is about the graph book. When should we start writing the? Okay, should we write the whole topic or just the graph one?
No, we are just doing the graph in the graph book. Okay? If we're having those numbers that need graph work, you do those questions in the graph book. But for the other work, your notes, you write in the notebook. That's what we say. All right.
Okay, do we have more questions?
We have hope.
We have more questions.
Is okay, maybe you can proceed for now.
Line of
and
so if there are no questions, there is this video. Okay, there are many videos on line of symmetry they can get online, but I'm going to play for them this one, which was made by our teacher,
symmetry.
One of the project. I don't know if my screen is visible.
A line of symmetry of a shape or an object is the line along which we can fold the shape to form two identical parts. Let's look at lines of symmetry of some shapes in the following examples. Example 1 is for a rectangle. When you fold a rectangle horizontally, you get two identical parts. When you fold a rectangle vertically, you get two identical parts. When you try to fold along the diagonal, you do not get two identical parts. Hence, a rectangle has two lines of symmetry, that is, a horizontal and a vertical line of symmetry. Example 2 is for a square. Fold a square horizontally. This gives us the first line of symmetry. Fold a square vertically. This gives us the second line of symmetry. Fold a square along one diagonal. This gives us the third line of symmetry. Fold a square along the other diagonal. This gives us the fourth line of symmetry. Hence, a square has four lines of symmetry, that is, a horizontal and vertical line of symmetry and the two diagonals. Our third example is a circle. Fold a circle along any line that divides it into two equal parts. This line is a line of symmetry. If we repeat along any line that folds the circle into two identical parts, then this line is also a line of symmetry. Let us try along another line. This line too is a line of symmetry. Keep trying along many lines. You will see several lines of symmetry. Therefore, a circle is said to have an infinite number of lines of symmetry.
Joseph? Joseph?
Yes, please.
Yeah, that is a video I picked from one of the projects that we have been doing, but there are so many videos they can get online if they're interested in understanding what a line of symmetry is. And from the video, they can see that
usually fall under the same genre.
a square has 4 lines of symmetry, and then a rectangle has only 2 lines of symmetry, and then a circle has infinite lines of symmetry. So they can do for the other shapes, and then they'll make their own conclusions. I see some hands up, Joseph.
Okay, I only see Manuela. You can unmute, then you submit.
Teacher, there are other videos for the other topic.
You can check on YouTube. I've not checked, but what I know, people have tried to make demonstration videos for almost all the topics that we've been studying. So you just need to select a topic of interest, and then you go on YouTube and you do a self-study. Okay. Can we hear from, I think there was a hand, I think the hand is down. Okay, any other questions?
I don't seem to see any. And
okay.
those in the chat, I have answered them. I think we are now okay to proceed.
Someone is asking that what is a rhombus? Can someone tell us what a rhombus is?
Manuela?
Rhombus is a slanting square.
Rhombus is a slanting square. So does that help you, Patricia Namboze? Yes.
Or maybe we need to demonstrate to her. But hope your hand is up. Maybe we can hear from you as well. Hope, unmute.
This is the same. Rhombus is a slanting square.
Okay, no problem. So
okay,
simply, okay,
yes,
you can demonstrate right that simply, if you have a square and you deform it, maybe you had. Remember, a square we are talking about. Just here, should we bring in the dimensions right now? I think you can first leave that.
You first leave that.
Yes. Yes. So if you have that square Sides are the same, both sides. And then you try to pull one edge. You can use one top of the edge, one edge at the top.
Okay.
And then you pull it horizontally. You will as if try to deform it. Yes, so it will form something like that.
Okay.
So
I don't know if it helps, but a rhombus,
yes,
is the shape of that kind.
When you form a square, then you form a rhombus. When you deform a rectangle, what do you get? Maybe we hear from them. How do you want to say something?
Parallelogram.
Someone said a parallelogram. Okay, we have Cynthia. Cynthia's hand is up. Maybe we can hear from her as well.
Yeah, it was the same thing.
Okay.
Okay. All right.
Okay, Joseph. I hope that helps us understand what the rhombus is. Okay, so they are going to do that exercise. They want you to find the number of lines of symmetry that you can have when you fold a rectangle. And you've just seen in that video that if you fold a rectangle, it's basically having two lines, the one in horizontally and then the other one vertically. When you try to fold along the diagonal, it doesn't fit perfectly. So you cannot get two similar, or you cannot get another line along the diagonal that can divide the shape into two equal parts. I don't know if that helps.
Okay, we have two hands up. Hope.
Excuse me, teacher. I had a question, but it's actually not about it's not about you're covering out. It's about plotting.
Maybe to understand what symmetry is, let's draw an isosceles triangle. It's a triangle.
Joseph.
Yes, please.
Let me play for them this other video. I don't know if my screen is visible.
Yes, so maybe you can first have it, then
the basics of
answer. Yeah, it might answer some questions here.
Basics of lines of symmetry.
Triangle in which two of its sides are equal. Now let me give you an easy task. You need to think if we can divide this triangle into two parts such that both the parts match exactly when they're folded along a line. How would you divide the triangle if this condition has to be satisfied? Fold it along a line such that both parts formed match exactly. Pause the video and give it a shot. It's easy, and I'm sure most of you would have got it right. If we draw a line like this, the condition will be satisfied. Yes, it's a vertical line which divides the triangle into two parts, which match exactly when folded along the line. If the part on the right is taken over to the left, we see that they overlap exactly. And that is why this shape is said to be symmetrical. The two parts match exactly when folded along a line. Now let me give you another figure. I draw the isosceles triangle this way and ask you the same question. How would you divide the triangle into two parts such that both the parts match exactly when they are folded along a line?
Mr. Theo, your mic is muted. We can't hear.
Yes, we can draw a horizontal line like this. We get two parts which match exactly. When one is folded or flipped, it overlaps exactly over the other. Both these lines we see here are called the lines of symmetry or the axes of symmetry. This triangle has a vertical axis of symmetry as this line is vertical, and this one has a horizontal axis of symmetry as this line is horizontal. Now I want you to think about the next question I'm going to ask you. Can a shape have more than one axis of symmetry? If you look at just these two triangles, you would probably say no, because there is no other line which can divide these triangles into two parts that match exactly. But the correct answer is that a shape can have more than one axis of symmetry. Look at this rectangle. These two parallel sides are equal, these two parallel sides are equal, and all four angles measure 90 degrees. It will have a horizontal axis of symmetry like this. When one part is flipped over, it will overlap exactly with the other. And it will also have a vertical symmetry like this. Flip this part and we see the perfect overlap. So a rectangle has a horizontal as well as a vertical line of symmetry. But wait, some of us may be wondering if the diagonals are also the axis of symmetry. Let's say we have a diagonal like this. You can see that folding it along the diagonal does not give us matching parts. You can try this with a page from your notebook. Try and fold it along the diagonal and you will see that the parts do not overlap exactly. Okay, here's another question for you. Can a figure have more than two axes of symmetry? If yes, then which figure? Again, the answer is yes. Take the example of a square. All its sides are equal and all four angles are right angles. It has a horizontal as well as
Okay, my network is not stable, but I guess the video is trying to help us understand what a line of symmetry is. At times they call it axis of symmetry. So as we wait for it to load, you can see that depending on which shape you are having, you can have so many lines of symmetry. So you need to try them out during your free time.
It's a vertical axis of symmetry, just like the rectangle. But for a square, the two diagonals will also be the axis of symmetry. If we fold it along this diagonal, the parts match. And even if we fold it along this diagonal, these two parts overlap exactly. So a square has four axes of symmetry: horizontal, vertical, and the two diagonals. More than four? What if we have a figure like a regular hexagon? A regular hexagon is a closed.
Okay, Joseph, I guess in the interest of time, I can stop sharing there, and maybe it gives them a bigger picture of what we are asking them to do. Okay, yes. So depending on what...
With 6 equal sides and 6 equal angles.
Okay, so depending on what shape you are having at hand, you can always find its line of symmetry, and they should be able to do that in the questions that I've given them in the runner's guide. Okay, so can we hear from them if there are questions before we can look at the Cartesian plane? Does the two videos we've shared, do they give you a picture of what a line of symmetry is? Once again, let me define it. A line of symmetry is that line which divides a shape into two equal parts. Okay? So they have already cheated for you on the triangle, but you have to do it practical and you determine what the question is asking you to do. So can we hear from them if there are questions?
By the way, teacher Steve.
Yes, Joseph.
Maybe that can as well be their project work. Eh? Yeah. They can try to form a number of shapes.
Hand is up.
Yes, we are going to attend to her. Thank you, Teacher Jennifer. So we are saying that can be their project work. They try to get papers. They get a circle. They form a circle, rectangle, a square, a rhombus, and then parallelogram. Because I talked about, then they try to demonstrate the lines of symmetry right there. Okay, Paul. Paul and
if a rhombus is a slanting square and someone parallelogram is a slanting rectangle, but then what is a trapezium or a trapezoid, and how are they different?
Okay, Joseph, maybe we need to clarify this. When you talk about trapezium, you're having the sides when they're equal. But a trapezium, the two opposite sides may not necessarily be equal. And then a trapezoid is a four-sided figure. It can be a trapezium, it can be a rhombus, you know. So a trapezoid is just a general term they give to those four-sided figures that are slanting. Eh? Does it help? Par?
Yes, it does.
Okay, can we hear from Vanessa at Kunda?
Teacher, I'm just saying, you say that a line of symmetry is a line that divides a shape into two parts, but like, okay, like maybe a rectangle, like along the diagonals, if you divide it like along the diagonals, I think that it will form two equal triangles, but so I think in the definition we should add which do not, which overlap perfectly, because like if you divide the rectangle in like the diagonals, it form two equal triangles, but they will still like overlap. So I think it should be added in the definition somewhere there.
Yes, Vanessa, when you talk of line of symmetry, the two, the shapes you form should be equal, and they should, if you fold along that line, one shape should fit perfectly on top of the other one. Eh? Okay, and that's why you're seeing that a rectangle you can fold vertically and horizontally, meaning that it has only two lines of symmetry. When you fold along the diagonal, it does not qualify as a line of symmetry because the triangles you are forming are not fitting perfectly. Okay, I hope that clears the misconception. So a line of symmetry has to divide a shape into two equal parts. So if a line is not dividing the shape into two equal parts, it does not qualify as a line of symmetry. Ineza, your hand was up. Can we hear from you? Angie? Ineza? Okay, if Ineza can't speak to us, I guess, Joseph, we can, if there are no more questions. Yeah. Yes, Ineza.
Teacher, are the diagonals of a square considered to be lines of symmetry?
What?
The diagonals of a square.
Yes, a diagonal can qualify
lines of symmetry.
It can qualify as a line of symmetry as long as the shape you are dealing with, that line divides the shape into two equal parts. You saw, for example, that a square has diagonals which divide the shape, and you form two triangles which match perfectly. So a square is one good example that has diagonals, and those diagonals, they divide that square into two equal parts. So a square has four lines of symmetry because it has the horizontal, the vertical, and then the two diagonals, one running to the left, then the other one running to the right. Okay?
Yes.
Okay, Joseph, if there are no questions, I see you have 7 minutes, but we need to give an overview of this activity.
Yes. I think we can proceed to subtopic 10.2.
Okay, girls, we told you that you're supposed to have a graph book. Now that graph book forms a plane. That surface, that paper, it's called a Cartesian plane because it has two sides. It has the horizontal side and the vertical side, okay? So it forms what we call a Cartesian plane. So you're going to be using that graph paper to plot these points. Unfortunately, this was supposed to be in groups, but now that we are away and we don't have time to form groups, we can, able reflect on what is given to us here. So they have given you 3 points. You have point P. Now, the way those values arranged, those are called coordinates. So the first value is the X coordinate, the second value is the Y coordinate. So when you're plotting, you have to know the order of those digits. Don't interchange. Some of us have that tendency of interchanging. So for example, P, it implies that X is 5, Y is 4. So you need to locate that point where 5 and 4 are meeting and you name it as P. Okay? Then you're having Q, which is -1 and +3. So it implies that X is -1 and Y is +3. So you have to locate where those two values are meeting and you call that point Q. Then you have R, which is represented by coordinates of 0 and -2, meaning X is 0 and then Y is -2. So they want you to present that work on squared paper, which we normally call a graph paper. Now, when you're doing this work, it is important that you do something which is big enough. So you have to bring in your knowledge of scale. I know you can use a scale of 1:1, but it might give you a shape which is small. Though I'm not saying that it's going to be wrong, but as you're doing this work, always aim for producing some work which is more visible enough. I don't know how the size is going to look like because I've not yet done it, but you're going to do it. So in part A, they are saying a mirror is placed on the x-axis. So it implies in this case that your x-axis is going to be the mirror line. I think it's easy if I take this to the whiteboard. Is my whiteboard visible, Joseph?
Yes, it is.
Okay,
Yes, it
great.
is.
So if it's visible, these are the points they want us to. So assuming I'm not going to draw a graph paper per se, but I can have the axis. By the way, your axis should be labeled when you're plotting this work. Okay. And then you plot depending on what values they have given you. So for example, here, if you analyze your points, you realize that you have a negative in Y and a negative in X. So make sure you divide your graph paper reasonably well so that all the points are catered for. Do not put your axis on one side, because that means there are points which will disturb you when you're plotting. So that's my y-axis, this is my x-axis, okay? So assuming I'm taking this as 1, 2, 3, 4, 5. Then going downwards, I'll have to use the same scale, -1, -2. Maybe I can stop at -3. Horizontally, I have 1, I have 2, I have 3, I have 4, I have 5. So that caters for all the positive values. Then on the other side, I have -1, I have -2, I have -3. Even if I stopped here because it caters for -2. So of course, the center here is 0, 0. Okay. Now they're asking you to plot these points. They want you to plot P. P is a 5 in X and a 4 in Y. Okay. So a 5 in X is there. It's this point, and then a 4 is there. So when you move across, you can locate where these two are meeting from. Okay. This point here. This becomes your P. Okay, so you call it P, and then you say P is 5, 4. Then you're having Q, which is -1, +3. -1 is here, +3 is here. So we want to locate this point, which is shared here, this one here. Okay, so I can call it point Q. And then the other side, I'll have -1, then 3. Then I have 0, -2. 0 in X is there, then -2 in Y is there. So that point is here. So I can call this one point R, which is 0 in X and then -2 in Y. Now, once you've attained, you've plotted these points well. Did they say we join? Let me check the question again. They didn't say we join, they just said we refract.
Yes.
Okay, so when you refract in X, what do you get? For example, what does P become? By the way, that is taking me to another point I need to. Yes, Michelle?
It becomes P 5 negative.
It becomes, because you're refracting through X, so X is your mirror line. Okay? Some people, when they are doing these numbers, they can, these ones can act like our mirror lines, but you don't need to put these ones. I'm just putting this for formality. Okay, but at the back of your mind, you need to know which line is acting as your refraction line. Okay. So Michelle has told us that it's going to be +5, -4, because P is going to go down. That means on your graph paper, you need to increase it so that you're having -4, then -5. What I was telling you, that you need to visualize and you see what space you need to use on your graph paper. Okay, so when you reflect it, it's going to go down somewhere here. You'll go down here and then you're going to call it an image of P, which I'm going to call P with a dash on top. So it will be 5, -4. So you can see that if I'm refracting through X axis, the X value doesn't change. It is only the Y value which is changing. You see that? If you're refracting through X, the value of X is not changing. It is the Y value which is changing. What else were they asking?
Excuse me, teacher.
Okay, yes.
When you were changing from you were changing these coordinates, is it like if let's say the coordinate 4 is positive, then when you're putting it on the mirror line, it changes to negative, or it's not the case?
It changes to negative because it's reflected in the opposite side. And in the opposite side, we have negative values.
Oh, okay. Thank you.
So you're welcome. You realize that the distance from X axis is vertical, it's 4. Those are 4 units. Then even below the X axis, you're having 4 units, but in the negative direction. That's why we were telling you that you need to understand that the distance from the object point is equal to the distance from the image point in reference to the mirror line or the refraction line. Okay? So any other question before we can sum it up? Okay. Our time is up.
Here we have Victoria, Melissa, can unmute.
Teacher, I wanted
Yes.
to ask if we do like the same kind of like lines you're doing, like the dashes.
Yeah, these ones are to help you rotate. But you know, if you're having a graph book, you can easily rotate the point. You just need to mark off that point where so that it's visible. These lines are just a by the way, but you can put them if they are going to make your work easier, though it's not a must.
Okay, thank you, teacher.
Joseph, do you have any other question?
Queen, did you
Teacher was asking, teacher, if can't you reflect it on the x-axis, but on the negative side?
If you reflect on the negative side, that means you'll be reflecting through y. So always do the question accordingly. Don't just reflect without following what the question is asking. I'm sure there are questions you are going to meet that they'll ask you to reflect through y. So if I reflect it through y, that means the y value will not change. It's only the x value which will change. Okay, I guess that should be some kind of an exercise for you people.
They can as well use their mirrors at home. If you're facing it, yes.
Me, teacher.
A minute, Marjorie. If you face your baby when it is hanging vertically, you'll see your image the other way, as if opposite. And then when you press it below, and then you step on it, you see your mirror just below that image. So try to experiment that. It will be very, very interesting there. Okay, Marjorie, you're saying something?
I was saying that, so these all x-axis is just like in the experiment which we did by the that this part, the first P was positive for this x-axis, the reflecting line or the mirror line, and this negative with the P with the negative 4 is the reflection.
Yes.
Oh, okay.
Yes, I said that.
Okay, Joseph, maybe before we wind up, you realize that in that question, they are telling them to reflect through other lines, x equal to, okay, y is equal to 2 and then x equal to 4. So they need to know how to draw those lines, Okay? They need to know how to draw those lines so that they can reflect well. Yes?
Excuse me, teacher. How do you reflect R? Yeah.
I've not got your question.
How do we reflect R? R equals 0, negative.
Okay. When you reflect, it goes up. Always remember that if you reflect a point, it moves in the opposite direction. So in this case, R will move upwards. And what does it become? It will be 0, positive 2. Okay? And when you reflect Q, it will go down. Joseph.
Yes, please.
This is what I'm thinking. For them not to congest their graph paper, I'm thinking they do part A, part B, and part C separated.
Yes.
You do part A on its own graph, on its own XY plane, then you get another graph paper, you do B, then you get another graph page, you do C, so that your work is not congested. I think it will make more sense. So girls, these are going to be 3 graphs.
So that is very important. Anyway, let's use maybe the 3 minutes to answer these. I don't know whether Hope just left the hand up. Marjorie, let's hear from Lina. Lina has not said anything. Lina, unmute.
Teacher, how do you know which number goes on the x-axis and which number goes on the y-axis?
Well, I explained that when I was starting. I said when they give you coordinates, okay, this first value is usually the X value, and then the second value is usually the Y value. So that's the order. Don't interchange fields. Okay, that's the order. Yes, Joseph, more questions?
Okay, let's hear from Charity Sharon. First, Charity Sharon.
Teacher, when they say that use the line y equals to 2 and x equals to 4, what do they mean exactly?
Okay, I saw that coming. Let me demonstrate for you. When they say y is equal to 2, it implies it's a line which is going through that y value. Okay, are you saying that? That's the line which is y equal to 2. It implies y is not changing. Eh? Okay, so it's a horizontal line going through y equal to 2. When they talk of x equal to 4, they are talking of a line which is going through x. Okay, x equal to 4.
But along.
So it's a vertical line. It's a vertical line which is equal to x equal to 4. So we need to know how to plot these lines. Eh? And now these are going to act as our mirrors when we are reflecting.
Maybe, teacher C, we can give them another example. Maybe say x equals -2. They can ask that as well. So you look out for the value which is -2 along your x-axis, then you draw a vertical line. That will give you x equals -2.
It is still the same knowledge. It's just a value, I mean, a horizontal line going through y equal to -2. It's still the same knowledge as the other one. So I guess that's a good hint for them. Unless if they are burning questions, we should end the session.
Excuse me, teacher.
Yes.
Charity, please.
Excuse me, teacher.
Yes.
So now when you draw x equals 4, where x and y meet, the new x and y meet, like how exactly do you use those new lines?
How do you?
How do you use those new lines that you've put?
Now, when you are starting, you're going to be having graph paper which is like that. Okay. Now, on that graph paper, you're going to locate where y equal to 2 is. You're going to locate where x equal to, but they are going to be separate graphs. Okay. Let me say this is my first graph. Okay. So you're going to use this to attempt part B. I think part B was y equal to 2. So that means this line is going through 2. So you use this to do the number. Leave the P, Q, R points where they are, okay? But you need to reflect them through this line. So this becomes like your mirror line. You get it? Then you go on another graph paper and you do the same thing. Okay? Do the same thing and then you plot a line going through x equal to 4. And that is what is going to act as your mirror line. Leave the points where they are. Yes?
Could you plot for us when there is that additional line? How exactly do you reflect the points?
Okay. Let me reflect for you 0.2. 0.2 was somewhere here. I think it was point R. 0, -2. So they are saying you reflect 0, -2 through x-axis. Now, when you reflect it, it implies that it's going to move on the opposite of this line, meaning that your point is going to be somewhere this side.
Yes, but 4 units from that line, because as well you're having this distance.
Yes.
So from where you're having a point 0, -2.
Are you seeing that distance from the mirror line? It is 4. So you are going to get 4 up to that side also. So meaning that it's going to take you to, I think, 8. It will take you
8
to 8 to -2.
Yes.
Okay. So when you reflect it, that's how you are going to. You can count the boxes if you want. Does it tell?
Okay, thank you, teacher. Yes.
Okay.
Yeah.
Okay, so I guess we can end it here, Joseph. Unless if there are questions.
Excuse me.
I don't know that these are burning questions. I don't know. But we need to remind those maybe as they leave, we need to remind them that we shall be having our math test on Monday. Hope you received the timetable on Monday, that is 6th, from noon to 1. Take note. Next week on Monday, noon to 1. And
yes.
And the timetables of the Google Classroom.
I shared that timetable in WhatsApp forum. Your parents should be able to give it to you, but we are going to post it even on the Google Classroom.
Okay, teacher, the test is going to be what we have covered during the online lessons or what we covered even at school time before lockdown.
Online classes.
Excuse me, teacher.
Yes?
We're going to be multiple choice.
Kind of. Like what we were doing previously. You do the number and then you tick off the correct answer.
Yeah, but I'm worried because there was a question and it was not coordinating with the answer you had written. Then we failed, but we had correct answer.
Yes,
or if it is our mistake, we shall handle that accordingly. But we are going to try as much as possible to reduce those errors. So if the fault is from our side, it shouldn't be a reason for you to worry.
Yes. So their worry should be just revising.
Can you revise and you understand the work, please?
Yes.
Also, teacher. Will they give the results immediately when you submit?
Yes, I'm going to set up that option. After submission, you should be able to see what you've earned or what you've got.
Electricity.
So when are we doing it exactly? Which
on
day?
Monday.
Monday between noon and 1.
Subjects shall we be doing?
Thank you.
Will we be doing any other subjects before math?
Listen, girls, there is a timetable which was shared, and you're going to be doing 3 papers per day. Okay? So you're going to do the papers from Monday, I think, up to Friday. So all the subjects you've been studying, you need to revise. No running. We shall be doing those tests throughout. So you need to make sure your gadget is charged so that you're in a position to do these questions.
Sure, what if you go off and you've not yet submitted, and when you come back and the test is?
Let's hope for the best. We shall guide accordingly.
Yeah.
Teacher will come on Zoom and then you log in as usual and you give us a test.
We shall be going to Google Classroom to do our tests.
Okay.
So those who have not been using Google Classroom, time for you to practice.
Yes, Teacher Theo.
Yes, please.
I understand our friends here who are living right now. I do talk with the rest who left earlier. Let me hope they will communicate to them, because we had over 200 something students.
Yeah.
And they might have missed out this information.
Yeah, we're going to pass on more information, Joseph.
All right, please.
Okay, girls.
Please go on.
I'm saying that I guess that's it from our side. And let's prepare adequately so that we are in a position to do these tests well. They should reflect your ability, the exact ability you have. Do not enter the test just for the sake of doing the test, please. Revise, prepare adequately. They are just like the normal tests we do at school. Only that this time around, we are doing them online. Okay? And the teachers will be there to troubleshoot whichever challenges we'll be having as we do the tests.
But it are they promotions?
I don't know. That's for the school administration and the government. So give them your best.
Okay. Will all the subjects be multiple choice?
I have no idea. But most of them are going to be. They are going to give you more guidelines.
Okay. But for math, that is our way forward.
Yes. Okay. Joseph, Martha, and Jennifer, thank you so much. I guess we should end the session here.
Please.
Yeah. So.
Teacher, for the lesson.
Excuse me, teacher.
Thank you for the lesson.
Excuse me, teacher.
Yes.
Yes, Hope.
Will there be any questions on fractions?
Sorry?
Will there be any questions on fractions?
Have you done fractions during the lockdown, the online classes? I want you to go back and reflect on the topics you've done during this period. If fractions were part of it, then expect it. Yes.
I have a question.
I have any question.
I get one at a time. Okay, Patricia. Okay, Joseph, I guess they are having no questions.
I have a question.
Marjorie, yes. Teacher. Okay, Neza.
So when we are reflecting, do we check both the X and Y axis?
Yeah, we reflect. We reflect
the opposites.
The coordinates to the opposite side. So whichever digit.
Both X.
Yes, both X and Y.
Okay, thank you,
teacher.
Yes.
Teacher, I have issues the nth. I didn't get it for the nth term. So in the next lesson, the Friday, can you please help explain the things for the nth term? Ma'am, it's disturbing me. I didn't get it well. That's the only I don't know for real.
Okay, Marjorie, I guess your issue is more kind of private. We shouldn't hold the whole class hostage. So maybe you can try to reach your teacher to see if you can be supported.
Okay.
But I know Mr. Chakonyi can handle that. I even don't know why you are disturbing us. Marjorie, did you ask Dad? Okay, can we end the session here, please? Nadongo, Elaine.
Okay.
I'm seeing a hand up, Elaine.
Teacher.
Yes, please.
I think our friends here are tired. They can use the classroom to post, which I'll be able to answer them.
Okay, sure.
Because some issues are private.
I know some issues are personalized. Okay, guys. We shall see on Friday. Yeah, let's end the session. Yeah, bye.
Excuse me, teacher.